Hey guys, today we're gonna talk about Hilbert Space.
If you are a physics student, then you may have learned about or heard about Hilbert space, but you may not know about what is Hilbert space exactly. The reason is actually Hilbert space is very high level mathematical concept corresponding to functional analysis and infinite dimensional vector basis. Also, it is corresponding to graduated math. However, you will only know about linear algebra and finite dimensional vector spaces. Today, I'll be the stepping stone for you, and my aim and my target is physics and quantum mechanics, not mathematics. And I'll give you abstraction of Hilbert space. Okay, terminology. In finite dimensional vector space, we will know about spanning. And spanning is the term when we can use in finite sum. However, in infinite sum or uncountable sum, which is corresponding to integral, then you should use terminology completeness. And as you know, complete basis means completeness plus linearly independent. When you say complete set, then the set should not be linearly independent.
Okay. In quantum mechanical axiom, the first one is every state lives in Hilbert space. In more detail, they live in league Hilbert space. Also, Hilbert space is our foundation, and we should understand it rigorously because it can affect other axioms like this Heisenberg relation or generalized statistical interpretation or Schrödinger equation. So, what is Hilbert space? Hilbert space is some kind of vector space and also some kind of inner product space, and also it should satisfy completeness. This is the other meaning of the complete basis, and this completeness is defined as every cosequence converges. Then what is cosequence? Cosequence. Sorry. Completeness means every cosequence converges. Then what is cosequence? Cosequence means every point converges to each other. It is weak form of the from kind of converge to some point. It means when you think about convergence, the sequence come to one point, right? But cosequence means they approach each other, but they shouldn't have to. They might not have to come to one point, approach to one point. Okay, so this is the weak condition. However, in Hilbert space, every cosequence converges. This means every weak kind of convergence have strong kind of convergence. This is the pros of Hilbert space. As a physicist, I can tell you this abstraction. Maybe mathematician hate this, but we should use naive language. So Hilbert space has no hole, and you don't miss any point. Okay, this is the abstraction of that definition. For example, L2 space, which means scalar integrable vectors, is kind of Hilbert vector space, and there is some in many cases with some useful and usual condition, every Hilbert space is isomorphic to L2 space. Theorem. So we can prove many theorem with the definition of completeness. So most important thing is spectral theorem, and this is almost same in finite dimensional vector space case, but yeah, it's same. The only difference thing is complete basis. not spanning basis. This is the only difference. So the reason why this theorem satisfy is there's no hole. So any state can be the infinite sum of other vectors. This tells us there's no hole, right? And there are also that kind of theorem, and they can tell the logical coherenceness of the axiom of quantum mechanics. If you have interest, then just read it.
Finally, actually, we should talk about liquid Hilbert space. Every state lives in liquid Hilbert space. This is a little bit correlation of Hilbert space. Then what did we correct? We just correct topology. We didn't touch set and any element. In weak topology, it's kind of sand, very smooth sand, and in strong topology, you can imagine pedal. Then X and P operator could be treated as singular because they are either direct vector function or unnormalizable. So they are treated as singular. But in weak topology, you can accept them. You can permit them. Okay, so they could be treated as regular. So rigorously, we should talk every state, every particle lives in linked Hilbert space. However, in bounded situation, you can always say particles lives in Hilbert space. Thank you.